Kính chào các đồng nghiệp đến tham gia cái buổi hội thảo khoa học CME của trường Y và Trung tâm Đào tạo Nhân lực theo yêu cầu của Đại học Dược tổ chức với sự tài trợ của công ty Novo Nordisk. Thì cái chủ đề hôm nay của chúng ta là từ cơ chế bệnh sinh tới giải pháp lâm sàng trong cái xử trí béo phì. Thì hôm nay chúng ta có tham gia của giáo sư Brian Oldfield từ Úc. Thì Professor Brian Oldfield. Thì chúng ta biết là đây là một cái buổi CME trong cái chuỗi CME béo phì của trường Y và Trung tâm Đào tạo Nhân lực theo yêu cầu. Thì chúng tôi đã làm một số cái buổi CME từ tháng 6 đến nay. Những cái buổi đầu là những cái CME về chẩn đoán và điều trị béo phì trong cái việc mà tiếp cận chẩn đoán béo phì ở bệnh nhân nói chung, và sau đó là có một cái CME về trên bệnh nhân đái tháo đường và một CME nữa là về cái tiếp cận và chẩn đoán béo phì ở bệnh nhân tim mạch. Thì đây là một cái chuỗi mà chúng tôi tiếp tục sẽ làm những cái buổi CME trên các cái vấn đề khác nhau ở nhiều cái lĩnh vực về phẫu thuật, về sản khoa, về nhi khoa và dinh dưỡng. Thì cái buổi hôm nay thì là một cái buổi rất đặc biệt. Chúng tôi mời được các giáo sư từ nước ngoài. Giáo sư Brian Oldfield là một giáo sư ở bên Úc chuyên về béo phì rất là nổi tiếng. Thì chúng ta sẽ có cơ hội để chúng ta sẽ nghe những cái thông tin từ giáo sư rất là quan trọng. Thì chúng ta biết là cái tình trạng thừa cân béo phì ở trên thế giới nó gia tăng rất là nhanh, và ở Việt Nam chúng ta cũng vậy, tăng rất nhanh. Thì theo cái thống kê gần đây thì chúng ta thấy là tỷ lệ thừa cân béo phì ở người trưởng thành hiện nay cũng khoảng là 6,6%, và đặc biệt là trẻ em thì cái sự gia tăng của thừa cân béo phì rất nhanh. Từ 2010 là 8,5% và lên đến 2020 nó lên gần như là gấp đôi, còn 19%. Và ở người trưởng thành chúng ta thấy cái tỷ lệ béo phì thừa cân cũng tăng rất nhanh. Và đặc biệt trong những nhóm bệnh nhân như là đái tháo đường, tim mạch, chuyển hóa đó, thì cái tỷ lệ béo phì cũng khá là nhiều, và đặc biệt là béo phì bụng. Như là những cái thống kê ở cái phòng khám quản lý đái tháo đường ở Đại học Dược thì tỷ lệ thừa cân béo phì nó lên đến khoảng 4%, và béo bụng có thể lên đến 60%. Và khi mà có tỷ lệ mà thừa cân béo phì tăng lên như vậy thì các cái biến chứng liên quan đến cái thừa mỡ, đặc biệt lượng mỡ tạng gia tăng rất là nhanh, rất là cao. Ví dụ như bệnh lý về tim mạch, cơ xương khớp, hoặc là những cái bệnh gan nhiễm mỡ liên quan đến chuyển hóa. Thì hôm nay thì cái CME hôm nay chúng ta có rất nhiều chuyên gia để chúng ta sẽ bàn về cái xử trí béo phì liên ngành, và chúng ta được mời những cái chuyên gia từ bên Úc là giáo sư Brian Oldfield và bác sĩ Quang Wei là chủ tịch của hiệp hội béo phì ở bên Singapore. Bởi vì bác sĩ Quang Wei thì bây giờ đang đi ở nước ngoài, cho nên cũng chưa tiện là tham gia ngay từ đầu chúng ta. Thì bác sĩ Quang Wei sẽ tham gia ở những cái phần sau ở cuối buổi sáng hôm nay, và chúng ta sẽ có một cái buổi CME cả ngày. Từ buổi sáng chúng ta sẽ nói về những vấn đề về nội khoa, từ cơ chế đến cái điều trị, và buổi chiều chúng ta sẽ có một phiên rất là đặc biệt, đó là về ngoại khoa với sự dẫn dắt của giáo sư Võ Duy Long, là một chuyên gia về phẫu thuật béo phì rất là nổi tiếng ở thành phố chúng ta và đã có rất nhiều kinh nghiệm. Giáo sư Long cũng đã mời được một chuyên gia từ bên Hàn Quốc chuyên về béo phì, phẫu thuật béo phì. Thì chúng ta hy vọng là chiều nay chúng ta sẽ có cơ hội chúng ta thảo luận những vấn đề mà liên quan đến cái phẫu thuật béo phì rất là quan trọng, để chúng ta có thể là biết cách mà chúng ta chỉ định và chuẩn bị khi những trường hợp nào chúng ta cần phẫu thuật béo phì cho người bệnh. Thì nói chung là đây là một cái hoạt động chúng ta cần phải có sự tham gia của nhiều chuyên khoa. Đây là một cái phối hợp liên ngành để chúng ta đạt được một cái thống nhất, và chúng ta đưa ra được những kế hoạch điều trị tốt nhất cho người bệnh. Thì hội nghị hôm nay không phải là chúng ta đơn thuần chúng ta cập nhật những kiến thức cái lai không, mà chúng ta cần cũng có những cái thảo luận xoay quanh những cái vấn đề về lâm sàng thực tế, và những cái ca lâm sàng chúng ta sẽ thảo luận về từ những cái thay đổi về lối sống, chế độ ăn, vận động, rồi đến những thuốc mới chúng ta cập nhật như nào, và chỉ định phẫu thuật, và chúng ta sẽ chuẩn bị cho phẫu thuật và sau phẫu thuật như thế nào. Có rất nhiều vấn đề chúng ta có thể thảo luận hôm nay. Thì với tinh thần đó thì tôi xin tuyên bố khai mạc cái hội nghị xử trí béo phì từ cơ chế bệnh sinh tới giải pháp lâm sàng. Trước khi đi vô cái phần chính của hội nghị Thì chúng tôi cũng xin thông báo một số cái quy định về tham gia CME. Để chúng ta đạt được cái cấp CME, chúng ta cần phải tham gia trên 90% thời lượng chương trình và đạt được trên 60% cái điểm post-test, và cũng cần phải upload đầy đủ các văn bằng và biên lai đóng phí. Đây là cái điều kiện bắt buộc. Và các đồng nghiệp tham gia cái buổi này thì chúng ta có thể chụp hình và chúng ta sẽ up lên cái đường dẫn mà chúng ta đã đăng ký ấy, để trong cái online như vậy chúng ta có thể quản lý được các cái thông tin chúng ta tham gia. Thì các đồng nghiệp có thể vô trong đường link để mình up các cái hình tham gia hiện tại ở hội trường này, để bên trung tâm có thể là nắm được cái thông tin mình tham gia như thế nào. Thì để đi vô chương trình nhé, thì tôi xin phép giới thiệu cái giáo sư Oldfield. Chúng ta có thể thấy xin slide. Em đeo cái slide của giáo sư Oldfield. Thì giáo sư Oldfield là giáo sư của khoa sinh lý, của cái khoa ở đại học Monash, và giáo sư là làm trong lĩnh vực béo phì. Giáo sư là tổng biên tập của cái tạp chí Review, Oldfield Review, và năm 2023 thì giáo sư đạt được cái giải thưởng thành tựu trọn đời của cái hiệp hội về nghiên cứu các hành vi về tiêu hóa, và giáo sư cũng là của chủ tịch và các thành viên điều hành của cái hiệp hội béo phì của châu Đại Dương về nghiên cứu về béo phì, và giáo sư cũng là cái phó chủ tịch của cái liên đoàn béo phì thế giới và đại diện cho cái bên châu Đại Dương. Và giáo sư đã có rất là nhiều kinh nghiệm trong cái việc đào tạo béo phì, và đã xuất bản rất là nhiều cái bài báo nổi tiếng trong lĩnh vực béo phì. Thì hôm nay chúng ta cũng rất may được giáo sư sẽ nói về cái cơ chế bệnh sinh. Thì giáo sư là chuyên về sinh lý, cho nên chúng ta sẽ có cơ hội chúng ta nghe những vấn đề về cơ chế bệnh sinh rất là sâu. So hi, Professor Oldfield. Không biết giáo sư có nghe được không? Thì có lẽ
tức là em cho cái âm thanh đây thêm âm thanh thường này là dành cho dịch không, ta phải làm qua đây đâu.
Nó bị tương tác. Vì cơ hội.
Can any
thì mình có thể trao đổi với cả giáo sư một chút, xong sau đó khi mà giáo sư nói thì mình có thể là nghe phần dịch thôi. Thì cái cơ hội mà được nghe giáo sư chuyên về béo phì, mà đặc biệt là làm ở khoa về sinh lý của đại học Monash, thì tôi nghĩ là một cơ hội rất là quý. Nên có thể là để giáo sư có thể thời gian rộng rãi, giáo sư nói kỹ cho mình cái phần về cơ chế bệnh sinh này cũng rất là hay. So hi, Professor Brian.
can you see my slides?
Yes. So because we would like to listen to your talk, so please just talk slowly.
I'm trying to show my
And,
slides.
yeah. Em chắc chiếu slide của, chứ để giáo sư chiếu slide luôn không?
Can you see my slides now?
Có thấy cái slide chưa?
Nó anh trao đổi với ông trực tiếp nữa.
Okay. So we can see your slide. So you can stop slowly, and we want to listen to your
Can you
talk.
see my slides and can you hear me?
Yes. We can see your slide. Yeah, now you can
Okay,
start.
are you happy for me to begin?
Yeah, you can begin to talk.
Yeah.
Please. Thank you.
Thank you. Well, thank you very much, and I'm sorry about that little bit of a glitch with the slides. It usually happens with these virtual conferences, but I want to say, first of all, thank you very much to Professor Nam and also my good friend and colleague, Quang Wei Tam, for her role and their role in inviting me to give this presentation today. It's certainly a great honor to be talking to this group. And I'm hoping, even though this is a virtual talk, I'm hoping that I can get to Vietnam in the near future. Now, I was asked by the organizers to give a talk on energy balance and understanding how we gain weight and why it is so difficult to lose weight. And I'm going to be talking about that mainly in regard to the second part of this talk, and why is it so difficult to lose weight, and particularly why is it so difficult to maintain that weight loss? Now, I appreciate that this is a very diverse audience, and so I will be pitching this to, I guess, what I see as the median understanding of these issues. But in terms of background, I think we are all agreed that obesity is a chronic multifactorial disease that is characterized by an excess of adiposity, which adversely affects health. Now, this was a definition that was put out by the World Health Organization last year, and it's widely held. The other thing that we are all in agreement on is that obesity represents a major impact on world health, and the numbers vary depending on how they're presented, but it seems that out of the 8.5 billion people that are living in the world, there are between 1 and 2 billion people living with obesity worldwide, and that depends largely on whether we take into account in these estimates the lower BMI that characterizes obesity in the Asian population, which is, after all, the most populous part of the world. I think we're all perhaps in agreement, although there may be some differences of opinion here, that despite public health interventions to limit food intake and also to improve its quality and increase energy expenditure, particularly in physical activity, the levels of obesity have continued to rise. Now, I've just included a note here to myself, really, to remind me that I've just seen some data recently, and some of you may have also seen this, coming out of the United States, which shows for the first time in a couple of decades that the incidence of obesity, the percentage of people living with obesity in the adult population of the United States, has reduced for the first time this year. So in the latest 2025 figures, the incidence of obesity, the percentage of those living with obesity, has reduced from 39.9% at the beginning of the year to something like 37%. So there's nearly a 3% reduction in obesity rates in the United States. And I think this is largely, and the correlation has been made with the uptake of the new anti-obesity medications. And I know my friend Dr. Town is going to be talking about that later in this session. And it also, that correlation between a reduction in the incidence of obesity and the uptake of these new medications is shown in the incidence of obesity reducing, particularly in the 40 to 65 year category, which is also the area or the group of people that have taken up these medications the most. So I think that's a promising sign. We know that weight loss, and this is going back to my earlier point, that weight loss due to lifestyle change is for the most part unsustainable in the long term. And this brings me to the point of my talk, that there are powerful and predetermined biological mechanisms that defend a pre-existing higher body weight. So the focus of my talk is to provide a primer or a baseline of understanding of the biological and genetically determined mechanisms that drive weight gain, but more importantly, as I've said before, make it so difficult to maintain weight loss over an extended period. And I'm hoping that a more complete or better understanding of these biological mechanisms will provide a better understanding of the new wave of anti-obesity medications that are based in a lot of the hormones that I'll be talking about, and a better understanding of the mechanisms and the drivers, the biological drivers rather than personal choice, will help to dismantle the weight stigma that we're trying to fight against in this area. Now, when you're asked to talk about energy balance, it's very difficult not to show a slide where there is a scale showing the relationship of energy intake to energy expenditure. And in a very simplistic way, this represents the old idea of it's just a matter of energy intake and energy output. And particularly in energy expenditure, this can be subdivided into a number of categories, some of which I'm going to talk about today, others I'm not. But energy expenditure clearly involves physical activity. It involves a process called adaptive thermogenesis that happens in brown adipose tissue, and I'll touch on that a little bit. I'm talking about basal metabolic rate. I won't be talking about this other issue of non-exercise activity thermogenesis, which is a type of activity that falls below physical activity or exercise. It's the sort of thing that I'm exercising right now, sitting down, speaking to an audience. It can also involve walking, just walking slowly. It can involve holding an upright posture. It can involve fidgeting. But these things have also been shown to contribute to energy expenditure. But in most cases, body weight, I just want to make the point that in most cases, body weight is maintained at a remarkably stable level, determined by what I'll be talking about quite a lot, and that's an individual set point of body weight that leads to the maintenance of this set point through a number of biological determinants. I want to just drill down a little bit on this idea of set point of body weight. And first of all, I'm going to talk about rodent studies that have supported the idea of set point. If you can see on the left-hand side, and I'm hoping everybody can see the cursor that I can, I'm pointing to the left-hand side now, and looking at rodent studies. These are rats, and in this population of rats, shown schematically on the left-hand side, they start off at a mean weight of about 400 grams, and then after a period, they are exposed to 30 days of food restriction, not necessarily starvation, but food restriction, and they lose some 25% of their body weight. But as soon as that food restriction is ended, they return to their normal body weight. And similarly, and I'll talk about how this is done, but if you undergo a process of overfeeding or force feeding in these animals, as soon as you stop the force feeding, they return exactly to their predetermined body weight. This is illustration of this idea of set point. And this is, on the right-hand side, another example from real-world experimental situations. And I'll say, in rats of this age, they increase their body weight steadily over a period of, this is about 200 days, but they increase their body weight. At a point about here, if those animals are force-fed through tube feeding, intragastric tube feeding, and with an increase in calories, they can increase their body weight until a point where that force feeding is discontinued here with the arrow, and they immediately return, not to the point that they started at, but along the trajectory of their control friends in this group to a point that is determined by set point. And similarly, if you undergo a process of food restriction, at the end of that process, they return immediately to this point that is determined by set point. Now, this is not only a feature of rodent studies, but also been shown in human studies. And I want to illustrate this in a very well-known, but an older, one of the original observations of this idea of set point as shown in human populations. This was done way back in 1968, but it's very often referred to and it's been supported by other evidence since. But it was conducted in a group of prisoners that's called the Vermont Prisoner Overeating Study. And it was done in 19 prisoners. Now this would be quite a difficult thing to do with the ethical constraints that we have today. But these prisoners were encouraged to overeat and by an increase in calories and gain an average of 21% in addition to their normal body weight. And 73% of that was in fat. And as you can predict, they had increasing fasting insulin, increasing fasting glucose, cholesterol, and higher levels of triglycerides, and a decreased glucose tolerance. But the important thing is that after 2 months after the overeating challenge, all had returned spontaneously to their original body weight. Again, supporting this idea of set point in the human situation. Now, one of the people that I admire a great deal in obesity research, George Bray, Professor Bray from the Pennington Research Center in Louisiana, also reported or self-reported his own attempts at overeating with some of his colleagues, and this work was published. But he reported on his efforts to maintain higher body weight by overeating, and what he found, just like in the prisoner study, that as soon as he stopped that compulsory overeating, he returned to his original body weight. Now, I just want to add to this a note that just as I'm a fan of George Bray, he was very much admiring of his mentor, Edwin Aswood, who gave a very famous presidential address to the Endocrine Society as early as 1962, where he said, "Obesity is a disorder which, like venereal disease, is blamed on the patient." And so this is one of the earliest recognitions of the importance of biological mechanisms, and one of the earliest insights into the stigma directed at those with obesity that are so prominent nowadays, but was recognized as early as 1962 by Astwood. Now, how does this play into, or how does this affect the body weight the weight loss that is so difficult to maintain over an extended period of time? How does set point relate to that? And here I'm looking at some older studies that again have been replicated many times, showing very similar results. But this shows the percentage of patients remaining at reduced weight at various time intervals following a weight loss. And this was a 9-year follow-up of 121 patients and their tendency to regain, which is independent of how they lost the weight, the extent of the fast, the extent of their weight loss during that fast, how long it took to generate that weight loss, and also the age at which they entered their obese situation. But the important thing to note out of this, that after 9 years, only 7 patients out of the 121, that represents about 5 to 7%, which is a very common figure after this period of time, remained at their reduced weight. So only 7 out of the 121 patients were able to maintain that weight loss over a long period of time. Again, reinforcing this idea of being drawn back to a set point of body weight. And this is shown diagrammatically in another series of observations with diet, that very low calorie diets, so in yellow, modified diet plus behavioral therapy, or a combination of very low calorie diets plus behavioral therapy over 6 months of this intervention. What we found over 5 years is that in each of those cases, the individuals undertaking these diets returned to at least their beginning starting weight. Again, showing a return to a body set point. So what determines the weight that homeostatic mechanisms desperately try to defend? One of the major determinants is genetics. It's been estimated that the genetic input to the levels of obesity amount to about 70% of the causes. Now, those genetics will determine brain pathways, and I don't want you to be too afraid of this schema here. We're going to come back to this and work through it a little more. But in addition to brain pathways determined by genetics, I could have added the way that hormones are released from the gut and the way that those circulated hormones are received or recognized in the brain changes in levels of obesity. The other important issue is the epigenetic phenomenon, the combination of genetics and environment. I'm often asked, when I say that genetics are a major determinant of obesity, why is it the case that we've had, and it's acknowledged that we have a genetic blueprint that's ideally suited to maintaining body fat? And this has served us very well over the millennia of evolution, where our genetic makeup has guarded against the famine that will usually come. And so our genetics have provided a way to hang on to that body fat in anticipation of a famine that will come. Now, people have said, well, if genetics are so important, why is it that we only had an obesity phenomenon worldwide in the beginnings of the 1980s? Because our genetics haven't changed in that period. But what has happened is that genetics meets a very different environment. We're no longer in a situation for most of the world where we have periods of abundance interspersed with periods of famine. But we have, for the first time in the 1980s, an abundance of high energy, high fat foods that are easily accessible. And so it's this perfect storm of genetics and environment that have led to this evolution. I just want to say that in terms of this caricature here, I was given this slide by somebody else, and I would prefer not to see that depiction of those living with overweight and obesity, which is perhaps disrespectful. And I've actually included it here just to make the point that these are perhaps depictions that we should avoid. So in addition to, I want to point out that in addition to these environmental factors that I've talked about the food availability, the changing of the high fat food market, the availability of changing in portion size, the reduced pricing, there are also societal changes that have happened more recently correlated with this increase in obesity worldwide, with changes in sleep, stress, and physical activity. These are environmental changes that also interact with our genetics and create an epigenetic phenomenon. To underline the importance of genetics, I wanted to again refer to some older data. This is some data that was derived looking at the BMI in intra-pair and their correlations within pairs between identical twins that are either, or in this case, monozygotic identical twins or dizygotic twins that are either reared apart or reared together. And this is a correlation in men and with women. And I think the important thing to take out of this is whether they are reared apart or reared together, there's a very good correlation within these pairs of their BMI. And there's no difference whether they are reared apart or reared together, showing the importance of genetics in determining their BMI. This is similar, even though there's less similarity in genetic makeup in the dizygotic twins. There's still a very good pairing of correlations, whether they are reared together or reared apart. This is also the case in some work that was done by Claude Bouchard, again an older study, but this is where they're looking at the effects of 100 days of overfeeding in pairs of identical twins. And what they find is that the compartmentalization of abdominal fat, or fat in the abdominal compartment is very well correlated between these twins over time. Again, showing the importance of genetics in determining not only the increases in body weight, but the way it's compartmentalized. I said that genetics are important. I want to make the distinction. There are monogenic causes of obesity that are rare but important. And these are things that you may or may not have heard about, but the melanocortin-4 or MC4 receptor deficiencies that exist in humans. Another one that I'll mention in some detail is the leptin deficiency, the inability to code for the hormone leptin genetically. But these are rare. For the most part, we are dealing with a polygenetic or polygenic model of genetic involvement. And so here I would make the point that the differences in predisposition to obesity are associated in this polygenic model with many genes with small individual effect sizes. And these are mostly operating in the CNS. And I want to illustrate that further by pointing out in a genome-wide association study utilizing a genome-wide polygenic risk score, the difference in these groups that were attributed to different risk scores between the highest and the lowest deciles of this risk score amounted to some 13 kilograms of difference in weight and a 25-fold gradient in the risk of severe obesity. And I would go back to the first point that and remind you that none of the individual variants account for a large proportion of the phenotype. And maybe the exception to this is some prominent gene deletions or genes that, for example, the FTO gene, the fat mass and obesity associated gene, that does account for increased appetite, increased preference for high energy foods, and high circulating levels of the hunger hormone ghrelin, which I'll be talking about, that are elevated after a meal. And so for every inherited allele of this FTO, there is about a 1 kilogram increase in body weight. In terms of any epigenetic models, I just want to add a few comments to that. The environment, as I've said, can drive epigenetic changes. These epigenetics, and we could go into this in great detail, but there's not enough time. But these are influenced by gene expression via DNA methylation, histone modification, non-coding RNAs. These are separate talks, and I won't be going into them. But in addition to the environment that I talk about, the food environment, there are other major considerations that are more and more considered now. And these are, for example, the nutritional status and food choices of mothers, either during preconception periods or in intrauterine development during pregnancy, will significantly affect the condition of their offspring. And this has also been shown not just for mothers, but also the epigenetic changes that come about after that follow habits of the paternal side, which is again another interesting area of discussion. But beyond this, one of the real-world, very famous examples of the epigenetic impact of food intake is in the Dutch famine in World War II, which when pregnant mothers were exposed to starvation periods, there was an increase in adiposity and adverse life outcomes in their offspring that happened post that war. So how is body weight regulated? And again, this is the diagram that I was asking you not to be too afraid of. It's a schematic showing the flow of these distributed neural networks controlling food intake and energy expenditure and energy homeostasis. Now, it doesn't matter where we start in this. Maybe we start here. Hopefully you can see my arrow. But if in response to food intake in the gut, and I'm talking about the GI, the gastrointestinal tract, but also involving in this process the liver, the pancreas, and the adipose tissue. There are changes in circulating signals, and I've listed a few of these, leptin being one of them, because I'm going to come back to that, but ghrelin and also circulating glucose levels. These signals are transferred to the brain, either via the circulation, but I don't think we should overlook the fact that they also impact on vagal nerves, sensory nerves going to these areas of the gut. And they impact on sites in the central nervous system, in the hypothalamus and brainstem, and these are largely responsible for the homeostatic responses that keep us in a homeostatic equilibrium in terms of our body weight. But they also impact on areas that are beyond homeostasis. These are areas of the brain that are in the limbic system that are involved in reward. They respond they generate food intake that is based around a hedonistic experience, not a homeostatic one. They respond to what we'd like to eat, whether we need it or not. It's what we'd like to eat. And overlaid on that is a level of executive control and decision making by higher areas of the cortex, the cerebral cortex, which based around stored representations of experiences with food, what we like and what we don't like, and what we think we should eat, what we shouldn't eat, what we feel guilty about. All of these things are processed in these higher areas of the cortex and involved in voluntary control, whereas these other homeostatic mechanisms are largely subconscious, involve autonomic or neural inputs and endocrine control of the changes in the gut. I did mention leptin, and I think it's worth drilling down on leptin as an important player in this. Leptin, it's always been known that there was a substance produced in adipose tissue that was produced in proportion to the level of adipose tissue in the body, whether this has been in animals or humans. And without it, there was no regulation of body fat. And this is shown here in this mouse that has a deletion of a gene and was incapable of regulating a gene that is responsible for signaling the amount of fat. And without it, they are unable to regulate their body weight and fat mass. And so this was known for several decades before Jeff Friedman at the Rockefeller University discovered the gene for leptin and sequenced that gene, identified the hormone that is produced from it, which he named leptin after leptos, the Greek word meaning thin. And the implication of this was that in this situation, for example, it was possible to give daily intraperitoneal injections of leptin into these mice that were genetically incapable of producing leptin and therefore grossly overweight. And they found that there were substantial reductions in body weight. Their percentage of body fat fell dramatically. They decreased in insulin glucose, and they had increase in temperature and metabolic rate, and physical activity as well. So this created a huge expectation in the 1990s that this was in some way a remedy for obesity. And this, but as I said, the genetic deletion that prevents humans from producing the lipostatic hormone leptin is very rare. And this is shown here in this 3-year-old boy that suffers from that deletion. And you can see, but what happened dramatically after the identification of leptin and it becoming used in the late 1990s, that this little boy was given daily injections of leptin, and after 4 years he was very normal in his fat distribution because of the replenishment of leptin. Now, unfortunately, as we all know, that the leptin did not live up to its pharmaceutical potential. Even though it's being revisited nowadays, it is not being the wonderful cure-all that we thought it would be. And this is largely because as obesity becomes more severe and more established, there is an insensitivity to circulating levels of leptin. And this phenomenon called leptin resistance is the sticking point for using leptin as a pharmaceutical approach. So I just want to now talk about long-term regulation of body weight through leptin. And I want to again drill down onto some detail. This is, for those that are not too familiar with looking at the brain, this is a cross-section, a schematic cross-section of the brain that involves, this is the midline, it's the basal part of the hypothalamus. And there is an area in the hypothalamus called the arcuate nucleus, which I'm tracing out now, which is deficient in a blood-brain barrier. So it's accessible to substances, hormones and other substances traveling in the blood. It's important to know that there are two types of neurons in the arcuate nucleus with opposing functions. There are those that contain pro-opium melanocortin, or POMC, and cocaine amphetamine regulated transcript. And there are others that contain agouti-related peptide and neuropeptide Y. These ones are orexigenic in that they cause increase in food intake and a reduction in energy expenditure to increase body weight. The partnering neurons that have opposing actions, they are anorexigenic and reduce food intake and increase energy expenditure. So to flesh that out, just to finish off, in situations where there is an increase in body weight and an increase in body fat, there's an abundance of leptin, and in that situation, there is an activation of these anorexigenic neurons that will tend to reduce body weight, reduce appetite, increase energy expenditure to bring us back to that point, that set point of body weight. And similarly in situations, if we lose weight and there's a reduction in leptin and a reduction in fat mass, then they will activate these orexigenic neurons, which tend to promote food intake. And they also inhibit, just to amplify these effects, they inhibit their adjacent anorexigenic neurons. So this is some of the mechanisms that have led us to understand more of the way that the brain controls a homeostatic control of body weight. Now that's in the long term. How about in the short term? Just a meal by meal changes that influence why we start a meal and why we finish a meal, which will in the end impact on body weight. And I'm going to go through this. This shows the brain and different areas of the gut. The areas of the brain that are highlighted are these hypothalamic control centers and brainstem control centers. This is labeled the dorsal vagal complex, an area of the brainstem, which is showing the stomach and GI tract, pancreas and adipose tissue. There is, importantly, a vagal sensory input to the stomach, which detects stretch that happens during a meal when the stomach is expanded, and that information travels via the brainstem to signal that we should terminate that meal. But then there are a host of other hormones that are released during a meal or anticipation of the meal that will regulate the size of that meal. One of them is cholecystokinin, or CCK, that activates similar chemosensory endings of the vagal nerve and similarly transported to the brainstem. Then there are hormones produced from the intestine, either the proximal intestine or the large intestine, that include PYY, 336, symptomodulin, the ones that we hear a lot about, GLP-1 and GIP, that are the hallmarks of medications that Dr. Tam will talk about later in this session, the involvement of Ozempic and Wegovy in the case of GLP-1, and in the combination of GLP-1 and GIP, tirzepatide or Mounjaro. But these are important in each of those so far that I've mentioned, important terminating a meal or increasing satiety. Similarly, there is amylin produced from the pancreas, along with insulin and leptin produced from the adipose tissue. The only, and the exception, this is important, the exception to that release of anorexigenic, or hormones that will reduce or increase satiety and reduce appetite, the exception is ghrelin. And this is the hunger hormone that I pointed out before. And this travels via the blood to the hypothalamus, and it's elevated just prior to a meal and will initiate a meal and decrease after that meal. I've highlighted these in red because they feature in this the next few slides. But I want to point out that it's reasonably easy to lose weight in the short term. But the question is, why is it so difficult to maintain weight loss? And what are the biological drivers that make it so difficult to maintain this loss? I want to start off by drilling down on appetite and energy intake. And I'm just going to do this with one study that I like a lot, not just because it was produced by prominent obesity researchers in Australia, Priya Samutharan and Joe Proetto, now quite a long while ago, but it actually holds up extremely well. And in this study, this group took a group of 50 overweight obese subjects, and they gave them a very low-calorie diet for 8 weeks. Then they allowed them to return to a recommended healthy diet and moderate exercise. They then measured hormones for 4 hours after a meal and compared these at baseline before they lost the weight, at 10 weeks, and at 62 weeks. So what happens, this is just weight loss, and you can see that they lose about 14% on average of their weight over this 10-week period of modified diet. And then similarly, as I pointed out, along with this weight loss, there's a corresponding reduction in leptin, which is a correlate of fat mass. And most of this weight loss will be in fat. The important thing though, and this is the data, is that normally I said that ghrelin will reduce after a meal. So this is the 4 hours after a meal. Here's the meal here. And you can see that ghrelin levels normally reduce after a meal and then start to increase over the next several hours just prior to the next meal. And this will initiate a meal. But the important thing is that 10 weeks and then a year later, this is the striking feature, that a year later, after this 10-week period, just 10 weeks of losing weight, these people never came back to the pattern of ghrelin production after a meal. It remains elevated. So, and similarly, in the converse way, these anorexigenic peptides that signal satiety or the termination of a meal normally would be elevated after a meal. But they, in each case, we're talking about PYY or amylin or CCK, they actually are not elevated as much after a meal, indicating that there is not such a driver to terminate that meal. And this is shown, in summary, if you look at hunger ratings after a meal, they would normally, shown here, this is the baseline data in black, they would normally go down after a meal, and the desire to eat goes down after a meal. But because of these persistent hormonal changes that exist up to a year later, they actually never are reduced as much as they would have been prior to that period of weight loss. So it's a memory of that weight loss that stays with that person for at least a year later. What about energy expenditure? What are the biological drivers that make it so difficult from this perspective? Again, one of my favorite studies, this is a study by Rudy Leibel from Columbia University. And what he showed in this pivotal study is that if you take a group of patients who have their initial weight here, and you cause them to either have 10% weight gain or 10% weight loss. If you look at the color coding and you look at energy expenditure here, that there is an increase in energy expenditure which fights against that weight gain, and a reduction in energy expenditure that is coincident with the weight loss, tending to try and bring these populations back to their initial body weight. It's a counteractive or an adaptive response to that weight gain or that weight loss. And I think one of the last examples is I want to highlight some data that came out of a TV show that I think highlights the lack of understanding of these biological drivers. This was an important or a popular TV show that may not have aired in Vietnam. I hope it didn't. But essentially it did have a very well followed US franchise of the TV program, The Biggest Loser. And in this group of participants that were competing to lose weight with very extreme situation of food, reduced food intake, of dieting and excessive exercise, you can see these are the data, these are the anthropometric data from this group. Right at the beginning, at the baseline levels, you can see that they, in terms of kilograms or BMI, they are very much in the severe obesity, class 3 obesity levels with high levels of fat and so on. But 6 weeks into this competition that we've got, so, yeah. So, okay, I'll just continue and perhaps we can have some questions later. Yes, it is a competition. But so 6 weeks into this trial, there is as the beginnings of these weight loss and reductions, but look at these data after 30 weeks in this competition. These people have gone from, say, look at the BMI figures, they've gone from class 3 obesity to something that is in the realm of Europeans overweight. There's a reduction in fat mass and unfortunately a decrease in fat-free mass. But these are fairly remarkable situations that occur after 30 weeks of this extreme diet and exercise. But I want to point out why it's so difficult to maintain this weight loss because of the metabolic adaptations that occur. I think this is quite profound data. This is the actual, if you look at resting metabolic rate here, and this is the baseline data, it's actual. The difference between predicted and actual is that predicted resting metabolic rate is determined by evaluation of different anthropometric values. But this is the actual, this is shown here, is the actual measured resting metabolic rate. We can see after 6 weeks, it's substantially reduced. And after the 30 weeks, the actual metabolic rate of these is considerably reduced by some 22% and very significantly reduced. So this is a dangerous signal. Now, it wasn't until six years later that there was a publication in obesity headed by a very well-known energy expenditure researcher, Kevin Hall and his colleagues, and they take the same cohort of people that were involved in this competition. They looked at different measures 6 years later, and they looked at 14 of the 16 original subjects who participated in the program. And you can see that the figures are roughly the same, but here's the baseline measures. So let's just focus on these measures of weight and BMI. After 6 years, these people have returned to their initial levels of obesity. They're still in this, after 6 years, they're back at their class 3 level of obesity. And you just compare these different categories, the baseline measures through 30 weeks. This is the data that was so impressive. There was a huge difference between those, but this difference disappears after 6 years, where they come back to normal. And what I really wanted to point out is that despite the very different data that exists 6 years compared to their remarkable weight loss at 30 weeks, there are very different populations now. If you look at the resting metabolic rate, it's still as low as it was at the 30-week period. So after 6 years, and this is quite amazing to me, after 6 years, they maintain this very low metabolic rate. which is driving them back to their predetermined level of body weight. So just to finish off, what I've tried to do is show you some compelling examples of hormonal metabolic adaptation after weight loss that drive a return to a pre-loss weight. There are many other components to this adaptation that I could mention that include changes in brain neurochemistry and circuitry that again form the scope of this talk. I just wanted to leave you with a take-home message that it's the more we understand about the basic biology of obesity, the better we can direct its treatment, the less likely we are to judge or stigmatize those with it. So with that, I'd just like to thank you for your attendance and look forward to trying to answer your questions in this session. Thank you. Thank you.
Thank Prof. Brian Oldfield. Chắc để tôi nói tiếng Việt cho nhờ dịch sang thì có lẽ là chúng ta sẽ có cái phần mà hỏi đáp sau cái bài giáo sư, sau đó để giáo sư nghỉ thì các đồng nghiệp có câu hỏi gì mình có thể nêu lên này liên quan đến về Linh. Chắc bác sĩ Long rất là
Sâu quá.
Rồi mời bác sĩ Pháp nói nhiều câu từ hay nói từ từ.
Dạ. Em xin đặt câu hỏi trước là thì trong cái phần trình bày của giáo sư Oldfield đó thì mình nghe rất là nhiều những cái nghiên cứu mà thường đại khái là khi mà cố gắng giảm cân sau đó thì giảm được và sau đó một thời gian thì cân nặng nó lại tăng trở lại và nó có một cái khái niệm gọi là set point trong cái điều hòa về cái cân nặng đó thì là mà trên thực tế thì có một số bệnh nhân đúng là khi giảm cân thì quay sau một thời gian sau sẽ bị tăng cân trở lại. Tuy nhiên cũng có một số người ta giảm cân rồi người ta giữ được cái mức cân nặng đã giảm luôn, là có thể là không biết là có những cái cách nào mà tạo một cái set point mới cho bệnh nhân hay không. Có thể là tạo một cái set point mới một cách từ từ cho những cái trường hợp đó người ta có thể là thích nghi với một cái thầy hormone theo một cái baseline mới vậy.
Yeah. If I can you hear me okay?
Yes.
If I can answer that, yeah. As I tried to point out, and these are very much the data that I showed you are very representative of the data that exists in virtually all of these studies. It's always about less than 10% to 5 to 7 years of people that can maintain their weight loss. Now, you're right, there are people that can maintain their weight loss. But this requires a huge effort given the very powerful genetic biological drivers trying to bring us back to that set point. Now, the only way that we can modify in a temporary way that set point with medications. But you appreciate, and I'm sure that Dr. Tam will talk about this later, that as soon as we come off those anti-obesity medications, then we will return, likely we'll start to regain weight again. The other way that is more permanent, and in a way that is poorly understood, is that after bariatric surgery, after the simple surgery, there is a resetting of set point that will last for a considerable time. Now, as we know with Roux-en-Y and gastric bypass, that there is a gradual weight regain over a number of years, and it's much slower than with other forms of weight loss. So in some way that we don't particularly understand, that bariatric surgery does have some effect on set. And that's about all I can add to that.
Xin cảm ơn giáo sư. Thì giáo sư nói về cái việc mà làm sao chúng ta tác động được cái set point đúng là rất là khó, bởi vì cái đó quy định bởi cái di truyền rồi. Nhưng mà đây giáo sư nói ra một số cái điểm chúng ta cũng có thể học hỏi được. Thì giáo sư có đề cập đến cái phẫu thuật mà gọi là bariatric surgery của bác sĩ Long đó. Thì sau khi phẫu thuật thì cũng tạo ra một cái điều kiện để có thể mình thay đổi được cái set point một cách có ý nghĩa trong một khoảng thời gian. Thì đó cũng là giúp ích cho chúng ta có thể là kiểm soát được cân nặng theo thời gian một cách thuận lợi hơn. Thì không biết là các đồng nghiệp có câu hỏi gì khác không ạ? Thì cái bài của giáo sư rất là nhiều cái thông tin về cơ chế bệnh sinh và các nghiên cứu liên quan đến cái béo phì. Thì tôi cho rằng là cái bài này có rất nhiều cái hay về sinh lý mà chúng ta cũng nên biết. Thì các đồng nghiệp có thể nghe lại cái video này trong cái app của Academy ấy. Thì cái app đó có thể chúng ta nghe lại nhiều lần chúng ta sẽ hiểu hơn. Nếu chúng ta dành cái thời gian chúng ta đọc cái bài này chắc cũng phải mất mấy ngày nữa. Có một câu
anh nào mà chắc là hỏi cái vấn đề về ngoại khoa Việt Nam là nó vấn đề ngoại khoa, chắc là nói việc mới dịch chọn mà, tức là cái bạn hiểu rằng hồi nãy nó có vấn đề một cái gọi là ghrelin. Khi ghrelin nó tiết ra nó tăng lên, nó làm tăng cái mức độ mà thèm ăn á. Mà ghrelin thường thường nó nằm ở chỗ cái phần vị của dạ dày, bờ không lớn phần vị là chính. Do trong cái phẫu thuật mà sleeve gastrectomy á là mình cắt bỏ một phần dạ dày, mình cắt sát cái phần vị, nó gọi là cái fundus, thì lúc đó là nó giảm bớt cái ghrelin. Tuy nhiên có một số cái phẫu thuật, ví dụ như là phẫu thuật cắt phẫu chỉ có sleeve gastrectomy mình mới bỏ cái dạ dày phần vị thôi. Những cái phẫu thuật khác là mình không có bỏ dạ dày, mình chỉ gọi là mình chỉ split, tức là mình cắt ngang rồi mình nối thôi. Thì những cái điều đó mình đâu có làm giảm cái ghrelin đâu. Thì hỏi ổng thì cái ghrelin cái vai trò thực sự nó như thế nào? Bởi vì trong một số cái phẫu thuật mà gastric bypass hay là mono anastomosis, bây giờ có những cái phẫu thuật mới bây giờ nó làm hạn chế thôi, nhưng mà thực chất thì cái ghrelin vẫn còn, mình đâu có bỏ phần vị, mình chỉ split, mình cắt ngang nó thôi chứ mình đâu có bỏ. Thì hỏi thực sự ông cái vai trò của ghrelin như thế nào? Vâng, trong cái vấn đề phẫu thuật ạ. Vâng.
Okay, good point. Thank you for that. I think that you have largely answered your own question. That it is true that by removing the gastric fundus in sleeve gastrectomy, where many people in the audience will appreciate that you remove some 80% of the stomach, you along the curvature. But the fact that in other forms of bariatric surgery, metabolic surgery, where the fundus is not removed, they are still effective in reducing or changing that set point. So I don't think there is a critical role of ghrelin by itself in resetting that set point. We've shown a number of other changes that occur immediately after bariatric surgery that are quite varied and will affect set point. For example, immediately after, in experimental animals, immediately after sleeve gastrectomy, there is an increase in metabolic energy expenditure in the ground adipose tissue immediately after the surgery. And that is transferred by the vagus nerve. So there are I guess my point is that there are a host of changes that happen after different types of bariatric surgery. And it's unclear which of the drivers that are most responsible for readjusting that set point. But there is something about the basics of bariatric surgery that are effective in changing set point. But I don't believe it's either solely or even majorly related to ghrelin.
Thì tức là cái vấn đề phẫu thuật thì không phải ghrelin không, mà nhiều cái set point khác nhau thì không. Thực sự cái vấn đề phẫu thuật của bây giờ như nó cũng khó. Hồi xưa tức là cái hồi thời mà mới bắt đầu là người ta đặt bóng, sau đó người ta gọi là làm cái vòng á, có nhiều cơ chế, nhưng mà sau này thực sự bây giờ vẫn là cái phẫu thuật của cái sleeve á, nó ưu thế hơn nha. Rồi mời học cái câu hỏi tiếp ạ.
Rồi có một cái câu hỏi online á, là hỏi về ngoài các yếu tố di truyền thì các yếu tố về lối sống hay epigenetic thì tỷ lệ can thiệp thành công giữa di truyền thì việc cái thay đổi môi trường sống, tức là thay đổi lối sống á, lifestyle medicine á, thì cái tỷ lệ là bao nhiêu % thành công? Chắc có thể là hỏi về cái thay đổi lối sống, lifestyle medicine á, thì tỷ lệ thành công là bao nhiêu?
Can I answer that? Okay. Yeah. Well, the difference is, as I tried to point out, that the success rate of lifestyle changes are very great in the short term. It's quite common in your patients to see a dramatic decrease in body weight through lifestyle changes, especially with very low calorie diets and so on, less so with increase in physical activity. But these, as I tried to point out, these things are rarely permanent because of the biological drivers. So in order to maintain a decreased body weight, it's environmental factors of lifestyle, including energy intake and expenditure, have to change in a permanent way. So any changes that you make have to be ones that you can adhere to for the rest of your life. And it's true that some of these other epigenetic factors, the environmental factors that I talked about, that are outside personal choice, and that is about food availability and the public health issues around changing the way that fast foods are available and so on, will improve our chances of maintaining that weight loss. So, and I think it's possible, it's just difficult. And so, yeah, that's pretty much what I can say about that.
Thank you. Và có câu hỏi cuối cùng để cho giáo sư, để chúng ta cũng không có nhiều thời gian đó, thì tôi muốn hỏi về cái hướng mà nghiên cứu về thuốc béo phì ấy. Thì hiện nay các thuốc béo phì điều trị ấy, chúng ta tác động vào trung ương để làm giảm cái lượng nhập về các năng lượng nhập là chính. Như vậy là trong các cái nghiên cứu hiện nay, cái hướng nghiên cứu hiện nay ấy, thì có những cái thuốc nào để tác động lên tiêu thụ năng lượng?
I think that question is best left for Dr. Tan later in the session. I'd be happy to defer to her expertise there. I saw numerous, I went to Obesity Week in Atlanta a month or so ago, and a lot of the trial data is released at that meeting, and I was extremely impressed with some of the new anti-obesity medications. For example, even those that involve amylin, which is an anorexigenic peptide or hormone released from the pancreas, it has some remarkable effects via the central nervous system. And I think what was so impressive about that is that it had very similar weight loss outcomes to the GLP-1 and the GLP-1 plus GIP agonists, but did not have the side effects. So I think on the horizon, there are some wonderful drugs in this new age, and I think it's a very encouraging point to leave this talk on, is that you are now equipped as physicians, when they become available in your country and in surrounding countries, to deal with this obesity crisis. But I was very impressed with the amylin analogs, mainly because they reduce the side effects that have been, the GI side effects and so on, that have been so important with the GLP-1 agonists.
Vâng, thì chúng ta cũng không có thời gian nhiều, trên tôi cũng thay mặt xin cảm ơn giáo sư đã cho những cái thông tin rất là hay về cơ chế bệnh sinh và những cái hướng mà chúng ta điều trị giảm cân béo phì, làm sao chúng ta đạt được cái mục tiêu là giảm cân và có thể duy trì được cái giảm cân đó về lâu dài theo cơ chế bệnh sinh. Xin cảm ơn giáo sư ạ. Tiếp theo thì tôi xin mời báo cáo viên tiếp tục.